Welcome to Space Oddities. In this video we're going to be looking at the story of Pluto and finally asking the question, could it ever be restored to being a planet again? Now, to answer that question we need to understand the series of events that led to Pluto being demoted as a planet in 2006 when it was relegated to the status of a dwarf planet. The story of Pluto, from its discovery to its demotion as a planet and beyond, is quite long, but it's incredibly interesting, so stay with us while we explain how and why Pluto went from planet to dwarf planet. To put the story of Pluto in context, we need to appreciate how the whole question of what a planet actually is has evolved, and how our definition of what a planet is has changed over time. By the end of this video, I hope you will appreciate that the demotion of Pluto was the culmination of a long and complex issue that has persisted for centuries without a resolution, even to this day, and is not as clear-cut as you might think. Well, I'm going to tell you all about that issue and why it matters. To commence our story, we need to start a long way back in time with the ancient Greeks. The term planet comes from the ancient Greeks. They noticed that there were points of light in the heavens that did not wheel around the celestial pole in predictable, graceful arcs as stars did, but instead seemed to follow their own paths across the sky. Sometimes these unwavering points of light, which did not twinkle like stars do, even appeared to move backwards in the sky. They named these celestial objects asteres planetae, meaning wanderers, from where we get the word planet. Until the invention of the telescope, the term planets referred to any of those objects which could be seen with the naked eye, moving against the fixed background of the stars. Thus, the solar system consisted of planets only as far out as Saturn, because those were the only planets visible to the naked eye. Uranus and Neptune could only be seen with the aid of telescopes, so their discovery would have to wait until 1781 and 1846 respectively, although Uranus is allegedly visible to people with exceptionally keen eyesight under perfect conditions. With the discovery of Neptune and Uranus, the solar system expanded to 8 planets. But then, in 1801, the asteroid Ceres was discovered by Giuseppe Piazzi. At just under 1,000 kilometers across, Ceres was considered to be a planet-sized object and was thus classified as a planet. It's not usually visible to the naked eye except under ideal conditions, as its magnitude varies from 6.7 to 9.3. Ceres was the first asteroid to be discovered in the main asteroid belt between Mars and Jupiter. Other asteroids of similar size and shape were later discovered and were likewise classified as planets. So many, in fact, that by 1851 the solar system consisted, as astronomers viewed it, of the 8 major planets and 15 asteroids, making 23 planets in total. It was clear that many asteroids, as we now refer to them, remained to be discovered. Here are some of the largest asteroids in the solar system. Notice that none of them are perfectly spherical, a fact that became clear as telescopes improved through the latter half of the 19th century. These were obviously very different objects to, say, the Earth or Mars. Many asteroids were also significantly smaller than the major planets, so following a suggestion by Alexander von Humboldt in the 1850s, objects in the main belt between Mars and Jupiter were demoted and reclassified as asteroids. The term asteroid had first been proposed by William Herschel in 1802. In 1841, the term minor planet also appeared as an alternative to the term asteroid. In fact, minor planet remained as an official sub-classification of planets until 1932. So let's just step back at this point and ask the following question. In the mid-19th century, what were the prevailing definitions among astronomers of planets and asteroids? Astronomers defined a planet as orbiting the Sun, spherical and large, whereas an asteroid was orbiting the Sun, possibly spherical, but smaller than a planet. There are some obvious questions here. How large does an object have to be to qualify as a planet? Ceres is so much smaller than the Earth, sure, but the Earth is so much smaller than Jupiter. Where is the cut-off point in terms of size between an asteroid and a planet? Now we can see that the definition of what constitutes a planet was pretty sketchy at most, but it didn't seem to matter. Asteroids were those bodies between Mars and Jupiter. Everything else in the solar system, with the exception of comets, was a planet. Most astronomers didn't really bother themselves too much with the definition of what exactly a planet was. It didn't have much bearing on their work. There was no reason why they should bother themselves with an angels on the head of a pin definition of what a planet was. There were 8 planets and that was that, and exactly how they were defined seemed obvious. But that is not to say that the question of what constitutes a planet was not being discussed. Prominent astronomers of the day added their voices to the discussion. William Herschel opined that a planet is a body which revolves around the Sun in an orbit nearly circular and of a magnitude sufficient to be visible by the naked eye, while just a few years later he would discover the planet Uranus, which was not a naked eye object, so his definition was demonstrably wrong. His son John later ruminated on how difficult it was becoming to classify asteroids. He said, "The discovery of these small bodies between Mars and Jupiter has complicated our understanding of what constitutes a planet. Their small size and irregular orbits makes them difficult to categorize." No less an august personage than the Astronomer Royal George Bedell Airy, who held that post from 1835 to 1881, added his voice to the discussion, stating, "The increasing number of minor planets discovered in the region between Mars and Jupiter necessitates a re-evaluation of our criteria for what constitutes a planet." Here was the expression of a dawning realization among astronomers that the question of what exactly constitutes a planet needed a more precise definition. French astronomer Urbain Le Verrier, who predicted the discovery of Neptune, thought the definition of a planet should be defined by its gravitational influence. He wrote, "A planet must exert a significant gravitational influence on its surroundings, distinguishing it from smaller bodies like asteroids." German astronomer Friedrich Wilhelm Bessel expressed the growing realization of the need for a better characterization of planets by opining, "As our observational techniques improve, so too must our definitions adapt to encompass the diversity of celestial bodies we encounter." But all these varying opinions did nothing to change the status quo. Astronomers continued to use imprecise definitions of solar system objects. And then, on January the 1st, 1930, an event occurred which was to have profound impact on the question of what exactly is a planet. On the first day of 1930, Pluto was discovered at the Percival Lowell Observatory in Arizona by the astronomer Clyde Tombaugh. He had been searching an area of sky where it was predicted that a planet should exist, thanks to observations which seemed to show that Neptune's orbit was being disrupted by the gravitational tug of another body further out. We now know that those observations were erroneous. There was no disruption to Neptune's orbit, and moreover, Pluto could not have been responsible for the observations even if they had been correct. It simply doesn't have enough mass to pull on Neptune in any measurable way. In the light of this, Tombaugh's discovery of Pluto can be seen as pure luck. Pluto is just a pinpoint of light which may never have been discovered were it not for Tombaugh's perseverance, photographic expertise and determination to find the mysterious planet. 2 months later, other astronomers had verified Tombaugh's discovery, and in March 1930 it was announced to the world. The announcement of Pluto's discovery made the front pages around the world, celebrating it quite rightly as a triumphant astronomical discovery. Little was known about this far-off world out beyond the orbit of Neptune because it was just a faint point of light in even the world's biggest telescopes, but that didn't of course stop speculation. The Knickerbocker Press of New York ran an article stating that savants, what you and I might call experts, had estimated that the new world was possibly bigger than Jupiter, perhaps stemming from the need for it to have a lot of mass to be able to affect the orbit of Neptune. It all fit the narrative. The solar system had an additional planet, possibly as big as Jupiter. Tombow's own estimate of Pluto's diameter, arrived at shortly after its discovery, was 14,000 kilometres, at least 6 times bigger than it actually is, but of a size which so obviously, for astronomers, identified it as a planet. Now, if you want to register any astronomical claim, like the discovery of a new planet or a new comet, a new asteroid or anything else, you have to report your discovery to an organisation called the International Astronomical Union, or IAU. The organisation had set itself up in 1919 to be the arbiter and certifier of any new astronomical discoveries, and could choose to accept or reject them. More importantly, however, the IAU is the body which decides what to name astronomical objects or features on them, like craters or mountains, but most importantly, it gets to decide how to categorise astronomical objects. The naming of Pluto, however, was not decided by the IAU in a break from convention. It was decided by running a public competition to name the new world, which was won by a British schoolgirl. Not long after its discovery, astronomers worked out what the orbit of Pluto looked like, and it was unlike any other planet in the solar system. Highly elliptical, the orbit is tilted at an angle of 17 degrees relative to the orbits of the other planets, which all orbit in a flat plane. Perhaps most interestingly, Pluto orbits the Sun in the opposite direction to all the other planets. Here was the first indication that Pluto was not like any other planet in the solar system. Estimates of its size had not really changed since its discovery. Earth-sized was still the best guess, but as it remained a mere pinprick of light in even the largest telescopes, its size was extremely difficult to gauge. Estimates of its distance were pretty imprecise too. It's not clear whether Pluto's odd orbit prompted the ringing of any alarm bells among astronomers with regard to how Pluto should be categorised, but it should have done. Pluto was different. It's an outsider. So this is what we see in telescopes, a distant point of light way out beyond Neptune, about which astronomers knew virtually nothing until the 1970s. A world thought to be the size of the Earth, but with much uncertainty. A planet which orbits in an inclined elliptical orbit, travelling in the opposite direction to the other planets, with each orbit taking 248 Earth years. Pluto has not therefore completed even one orbit around the Sun since its discovery. Assumed to be icy or rocky in nature, this strange world kept its secrets out there in the dark on the edge of the solar system. Pluto was an enigma, and one which could be only fully understood by sending a spacecraft there, but there was no appetite for that. But then, in 1978, there was a major discovery. Remember that Pluto's just a point of light in even the world's biggest telescopes, and if you zoom in on it, you end up with just a fuzzy ball, like the images shown here. There's no surface detail you can see. Pluto's far too far away for that. It's just an indistinct, very roughly circular blob. But these images show something else, something which had not been seen before. Can you spot what it is? James W. Christie made the discovery on June the 22nd, 1978 at the US Naval Observatory in Flagstaff, Arizona. This was only about 6 miles from where Pluto itself was discovered at the Lowell Observatory. Christie was trying to refine Pluto's orbit around the Sun by repeatedly photographing it at maximum zoom, if you like. However, he noticed that images of Pluto were strangely elongated, which you can see here. The blob seemed to move around Pluto as well. The direction of elongation cycled back and forth over 6.39 days, Pluto's rotation period. Searching through their archives of Pluto images taken years before, Christie and colleagues found more cases where Pluto appeared elongated. Additional images confirmed he had discovered the first known moon of Pluto. It received the name Charon from the Greek Charos, meaning fierce or brightness. With half the diameter and 1/8 the mass of Pluto, Charon is a very large moon in comparison to its parent body. Its gravitational influence is such that the barycenter of the Plutonian system, the barycenter meaning the point around which two bodies co-orbit each other, lies outside Pluto, and the two bodies are actually tidally locked to each other, which means that from Pluto you only ever see one face of Charon, and vice versa. This beautiful image of Pluto and Charon was taken in 2015 by NASA's New Horizons spacecraft when it flew through the Plutonian system. It was the first spacecraft to ever visit Pluto. You can see how large Charon is compared to Pluto, half its size. Not long after Charon's discovery, astronomers calculated what its orbit around Pluto told us about the size and mass of each body. The results were surprising. There was no way now that Pluto was the size of the Earth, not even close. Pluto is more the size of an asteroid than a planet. We now know, thanks to discoveries made by the New Horizons spacecraft during its approach to the Plutonian system, that Pluto actually has 5 moons. Here they are in comparison to the size of the Earth. For the next chapter of our story, we need to go back to the year 1951. At that time, astronomers' view of the solar system divided it into 2 main zones. The inner zone, comprising the rocky or terrestrial planets, that is to say Mercury, Venus, Earth and Mars, and the outer zone, comprising the gas giants Jupiter, Saturn, Uranus and Neptune. Between the two is the asteroid belt. However, in 1951, Dutch astronomer Gerard Kuiper proposed a 3rd zone, which became known as the Kuiper Belt. This zone, said Kuiper, is a reservoir of comets, thus explaining where many comets came from. At the time this made some sort of sense because we didn't know the origin of many comets, and especially not long period comets. He described the eponymous belt as a disk of icy bodies, i.e. comets, beyond Pluto. Kuiper, however, thought that apart from comets the belt would be empty, and so it went for the next 40 years. But then in 1992 a team who had been surveying the Kuiper belt made a discovery, and it wasn't a comet. David Dewitt and Jane Liu found the first Kuiper belt object after 5 years of astronomical observations. It was designated 1992 QB1, later changed to Albion. Albion's between 108 and 167 kilometers in diameter and orbits the Sun every 296 Earth years. Its distance from the Sun varies between 41 astronomical units, or AU, 1 AU is the distance from the Earth to the Sun, and as far as 47.7 AU. It has a reddish colour. But the important thing is that this was a body of type unknown but too big to be a comet, in a zone of the solar system where there was not meant to be anything except comets. This was, to coin a cliché, a game changer. Because where there was one object, there were almost certainly more. And it wasn't long until many more were discovered, so many in fact that it's now estimated that the Kuiper belt contains more than 100,000 icy bodies. The belt is the last outpost of the solar system. Beyond that, far beyond that, is the Oort cloud, a huge reservoir of long-period comets, perhaps trillions of them. We're pretty sure that the Oort cloud exists, and that is where long-period comets originate rather than from the Kuiper belt, but its existence is nonetheless still hypothetical. With the discovery of the first Kuiper belt object, and the reasonable expectation that more would follow, attention turned to the question of exactly what these objects were and how they orbited the Sun. This was also of growing importance because, due to various reasons, the Kuiper belt was said to begin at 30 astronomical units from the Sun, that is 30 times the Earth-Sun distance. But Pluto, back in the 90s, was 39 AU from the Sun. In other words, Pluto is a Kuiper belt object. It's the closest one to us, but definitely a denizen of that outer solar system zone. After more icy objects were discovered in the Kuiper belt, didn't it make more sense to devise a special category for them? The American astronomer Frederick C. Leonard had pondered the existence of such a population of objects not long after Pluto was discovered in 1930. He wondered if it was, quote, likely that in Pluto there has come to light the first of a series of ultra-Neptunian objects, the remaining members of which still await discovery, but which are destined eventually to be detected, unquote. Notice his contemplation that Pluto was a member of a completely new class of objects. As more and more of the population that Leonard had pondered were discovered, astronomers realized the necessity of coming up with a name to refer to them. So they did. The name was Trans-Neptunian Objects, or TNOs. 1992 was a momentous year for astronomical discoveries. As well as Albion, astronomers also detected the first exoplanet, in other words, a planet orbiting another star. It may seem obvious that other stars have planets too, but it was by no means a given back then. The discovery of the first exoplanet, actually two were discovered at the same time, is relevant to our story, but we'll come back to that later. A year later, and another term was coined. This was the Plutino. 1993 saw the discovery of a Kuiper belt object that had roughly the same orbit as Pluto and had the same orbital resonance with Neptune, 2 to 3. This means that for every 2 orbits around the Sun completed by the object, Neptune completes 3. These objects were named Plutinos because guess which was the first ever discovered? Yes, Pluto. Plutinos form the inner part of the Kuiper belt and represent a quarter of its known objects. They are a class of object all of its own. But the question was, of course, are they planets? In the years that followed, more TNOs were discovered. But then, in 2003, one was discovered which really upset the proverbial apple cart. Its name is Eris, after the Greco-Roman god of strife and discord. Its name could not have been chosen more appropriately. You see, Eris appeared to be slightly bigger than Pluto. NASA immediately described Eris as the solar system's 10th planet. Just how many planets was the solar system going to end up with? If there were thousands of TNOs awaiting discovery which are comparable in size to Pluto and Eris, would the solar system therefore include thousands of planets? When it was also discovered that Eris has its own moon, it muddied the waters even further. Eventually, incidentally, it was found that initial estimates of Eris' size had been wrong and that Eris is actually a tiny bit smaller than Pluto, although it does have more mass. Well, I hope you can see that the situation was getting complicated. There was a growing call from astronomers and planetary scientists to, once and for all, define exactly what a planet is and what it is not. Moreover, since astronomers were finding more and more exoplanets, the need for a rigid classification of the bodies orbiting a star was becoming ever more pressing. If we cannot adequately characterize the objects in our own solar system, what chance would we have of using the correct classifications when talking about other star systems? Especially when nobody knew if we would discover completely unknown types of objects orbiting other stars. Rumblings in the astronomical community continued, and the matter finally came to a head in 2006 in Prague, capital of the Czech Republic. There, the IAU was to hold its 26th General Assembly. Remember, the IAU is responsible for approving names, categories and features of astronomical bodies. The issue of what constitutes a planet was to be discussed. The objective was to come up with a new and definitive definition of a planet. If Pluto matched the definition, it would remain as a planet. If not, then some other category would need to be bestowed upon it and objects like it. A new definition of a planet was proposed to the Assembly by astronomer Mike Brown, Professor of Planetary Astronomy at the California Institute of Technology. Brown was the person who had discovered Eris, which was, initially, as you will recall, thought to be larger than Pluto. Brown no doubt saw the need for changes after his discovery of Eris and wanted to be the person to push for those changes. Supporting his proposal was the president of the IAU, Catherine Cesarski. Despite later writing a book entitled How I Killed Pluto and Why It Had It Coming, Brown has always maintained that his intention was not to strip Pluto of its planetary status. That would merely be a byproduct of changes to the definition of a planet. He merely wanted people to recognise that the solar system had changed and new definitions were needed, and the public needed to be educated a little more about what was really out there at the edge of the solar system. Let's examine Mike Brown and Catherine Cesarski's proposed new definition of a planet. Brown's proposed definition of a planet comprised just 3 criteria. Let's take them in turn. 1. A planet is a celestial body which orbits the Sun. Well, that sounds reasonable, no? That might be many people's definition full stop of what a planet is. Nothing controversial there. But hang on, he says the Sun orbits the Sun. So what about those exoplanets orbiting other stars, of which more than 5,000 have so far been discovered? Are they not planets after all? Does this definition fail at the first hurdle? Well, that's not a good start, but anyway, so far Pluto hangs on to its planetary status because it does orbit the Sun, yes. 2. It is almost spherical. Sounds okay. All the major planets are mostly spherical. Pluto is mostly spherical too, so survives being a planet. So far so good. 3. It has cleared the neighbourhood around its orbit. This means that it has become gravitationally dominant and there are no other bodies of comparable size other than its natural satellites or those otherwise under its gravitational influence in its vicinity in space. And here is where Pluto lost its planetary status. Pluto has not cleared its orbit of other bodies. The other Plutinos that we discussed orbit in its vicinity. But note this, the phrases cleared the neighbourhood and in its vicinity are imprecise and undefined. What exactly constitutes a neighbourhood? How close do other objects have to be included in Pluto's neighbourhood? Similarly, in its vicinity, how far does Pluto's vicinity extend? 1,000,000 miles? 10? 50? 100? These terms are not the precise ones we expect from astronomy, where precision is everything. There's no room in science for ambiguity, after all. Also, clearing the neighbourhood has more to do with the body's mass, not the distance to other objects around it. Pluto's mass is so low, in fact, that it's impossible for its gravity to have cleared out its orbit. Surely some reference to an object's mass should have been included in this criterion. We can see that Brown's proposal, on which the final vote was to be taken on the last day of the IAU assembly, was vague and ambiguous. It was certainly far from an ideal definition of a planet. It fell at the first hurdle by insisting that a planet orbits the Sun, as if extrasolar planets don't exist. It failed to quantitatively define the terms neighbourhood and vicinity. Surely the vote would not go in favour of Brown's proposal. And so we finally come to the vote. It was the closing ceremony of the IAU 2006 assembly. 2,500 astronomers, representing 10,000 professional astronomers around the world, had attended the assembly. It was not usually the case at IAU assemblies that most delegates attended the closing ceremony on the last day. Many, in fact, had left the day before. So many, in fact, that when the time came for the vote, just 424 delegates remained at the closing ceremony when the vote on Brown's proposal was due to take place. Brown's moment had come. The vote was taken and it was carried. Suddenly there was a new definition of a planet, and poor Pluto was unceremoniously dumped from its planetary status. The solar system now had 8 planets, not 9. After 76 years, we finally knew what Pluto was not. It was not a planet. So, what was it? Well, after the vote, the remaining delegates agreed on a new classification of solar system objects, dwarf planets. This new category included not just Pluto, but the main belt asteroid series, plus the Kuiper belt objects Eris, Haumea, and Makemake, a total of 5 dwarf planets. Hurriedly, some delegates tried to recognise dwarf planets as actual planets, but this was defeated. Had the vote been taken before most of the delegates had left, would the vote still have been carried? Very probably not, although of course we'll never know. We can surmise that the vote would have gone against Brown due to the immediate and fierce reaction from astronomers when they learned that their own professional body, the IAU, had just declared that Pluto was not a planet anymore. They were not, to put it mildly, happy. Did Brown and Ciesielski intentionally wait until the room was nearly empty to hold the vote so it was more likely to succeed? Perhaps. The timing of the vote does seem as if it were premeditated. In light of this, can we say that Brown and Ciesielski fixed the vote? Maybe. If they had wanted forthright and honest debate, if they had wanted to hear the opinions of the world's astronomers, not just those represented by the 424 remaining delegates, they would have taken the vote sooner in the assembly. This can be argued about, of course, but one thing was certain: neither Brown nor Cesarski could have been prepared for the global furore they had just unleashed. Global reaction ranged from sheer disbelief to outright anger. It seemed such an arbitrary, hurried decision. Textbooks would have to be rewritten, although, of course, this does happen on a continuous basis with astronomy. Children in schools would now learn about a solar system comprising 8, not 9 planets. Pluto was relegated to a dwarf planet. Still a little bit of a planet, obviously, but of definite inferior status to actual planets. Brown had got his way and killed Pluto. While he maintains that was not his intent, that's what happened, and it was an inevitable result of his emphasized definition of a planet that had been agreed upon by a small number of delegates at the IAU Assembly. One astronomer said afterwards, "I'm embarrassed for astronomy. Fewer than 5% of the world's astronomers voted." This embarrassment was shared across the globe by professional astronomers. The media went wild, scenting blood. Nothing sells like controversy after all. The airwaves and the internet were filled with diatribes against the decision. Demoting Pluto as a planet has been probably the most controversial move in the history of astronomy, with entrenched opinions on both sides. There was literal global outrage. In the US, several state governments publicly denounced the demotion. Now, there weren't exactly riots in the streets. Oh, wouldn't it be wonderful if people felt so passionately about their universe? But the level of public anger was immense. Now, there was a minority of astronomers who thought it was a good move, citing the reasons we've discussed, but most seem to be totally against the idea. Many still are. But why do so many people want Pluto to be a planet when, as we have seen, there is little justification for putting it in the same category as, say, the Earth or Jupiter? I think a lot of it has to do with nostalgia. People want things the way it was when they were young, when the solar system had 9 planets, when you could depend on things, when things didn't change. I firmly believe that a lot of the protest about Pluto losing its planet status is simply nostalgia for lost youth. This image is of a book from my own collection. It was published in the early 1950s. Like many other people, I grew up with books like this, marvelling at the endless possibilities of space exploration. Yes, of course this book had Pluto as a planet, but it also had Jupiter possessing 12 moons and Saturn 9. Well, we now know that Jupiter, at last count anyway, has 95 moons and Saturn an astonishing 146. The point is that finding more moons around planets has been accepted without protest. The solar system has changed almost beyond recognition from the one portrayed in Adventures in Space. Yet nobody, as far as I'm aware, has ever written angry letters to newspapers when new moons have been discovered. So why protest so strongly about Pluto, whose demotion from planet to dwarf planet can be seen as a natural process, resulting from astronomers learning more about the solar system? So let us now at last return to ask the question we posed at the beginning. Is there any possibility that Pluto will ever regain its planetary status? Well, I think the best we can say is that it's highly unlikely, but not out of the question altogether. You see, scrutiny has recently returned to those criteria approved at the 2006 IAU Assembly. So what's happened? Dr. Jean-Luc Margot, a professor in the Department of Earth, Planetary and Space Sciences at the University of California in Los Angeles, and his colleagues from the US and Canada, have recently completed a study which proposes yet again a new definition of a planet. It's been published in the Planetary Science Journal. It recognizes the deficiencies of the 2006 definition while seeking to establish a more natural, logical way of defining what a planet is. Moreover, it does not seek to limit the number of planets in a star system. If, under the new definition, a star system has 50 planets, then so be it. Let's have a look at the proposed definition. The new proposal has again 3 criteria. Number 1, a planet orbits one or more stars, brown dwarfs or stellar remnants. This replaces the reference to a planet orbiting the Sun, as it now includes any stars, brown dwarfs or stellar remnants, things like neutron stars or pulsars. Don't forget that the first 2 exoplanets ever discovered were found orbiting a pulsar. Number 2. A planet has more mass than 10 to the power of 23 kilograms. This criterion imposes a lower mass limit for a planet. But why 10 to the power of 23 kilograms? Well, that's considered to be the minimum mass a planet needs to have in order to pull itself into a spherical shape and clear its orbit of other objects. At a stroke, it replaces 2 of the previous criteria. And number 3, a planet is less massive than 13 Jupiter masses, that is 2.5 times 10 to the power of 28 kilograms. Now this criterion sets an upper mass limit for a planet because anything with more mass, more than 13 times that of Jupiter, is considered to be a brown dwarf, a sort of intermediate stage in terms of mass between a planet and a star. These new criteria, which obviously have to be voted on at an IAU assembly, Professor Margot wants to put it to the vote in 2027, seem eminently sensible, less ambiguous and definitely more specific in terms of numbers than the 2006 definition. Professor Margot spoke to Universe Today and he had this to say. Basically, he's saying that the upper mass limits in his proposal lead naturally to the solar system with C, with 8 planets. Pluto does not have the minimum mass. In addition, he proposes that instead of a planet having cleared its orbit, it needs to do so within a specific time frame, which again will depend on its mass. By adopting a system which defines a planet by its orbital element and its mass, the whole business of defining a planet becomes much simpler and can be applied to any star systems. And with the rate at which exoplanets are being discovered, we do need a far more rigid, easy to apply system to classify objects around other stars. So where does this leave Pluto? Under the new proposal, Pluto is not defined as a planet because its mass falls below the lower limit. But that's not to say that at some point in the future, new discoveries may necessitate the redefining of a planet again, and Pluto might be restored. It seems unlikely now, but that may not always be the case. Astronomy is constantly changing, ideas change. So for all you lovers of Pluto as a planet, don't give up hope. The important thing to remember is that just because a body like Pluto is currently considered a minor player in the solar system, that's not to say in any way that it is less worthy of study. When NASA's New Horizons probe flew by Pluto in 2015, it discovered a dynamic, changing, enigmatic world with its own marvels and scientific challenges. It's an amazing object in the solar system which needs to be revisited. Ignore the fact that it's now a lowly dwarf planet. Pluto is one of the most interesting objects in the solar system, whose origins and evolution will take many years to understand. After all, what's in a name? Well, we hope you have enjoyed this video about Pluto and that you will subscribe to our channel if you haven't already. We create videos like this all the time. Don't forget to watch our Tuesday live streams when we bring you the latest astronomy and space exploration news, discussions, special guests and a lot more. If it's happening in space, it's happening on Space Oddities. Thank you so much for watching, and until next time, goodbye.